5 and we are going to present our project about rational functions. My name is Fer.
My name is Giselle.
My name is Omar.
My name is Jesús.
And my name is Ilia. A rational function is a fraction of polynomials. So if we have p and x and q and x that equals the polynomials, then the formula would be p and x divided by q and x. And a piecewise function is a function that is a sequence of intervals, and most of the times they have restrictions.
Asymptotes. An asymptote is a line in the graph that approaches but never touches. There are two types of asymptotes, vertical and horizontal. Here is an example of vertical asymptotes and how to get them. First, you have to factorize, and once you have already factorized, you have to evaluate to 0. Once you already evaluate to 0, you get the factors of vertical asymptotes. Here I'm going to put an example of already factorized function. Once you have already factorized the function, you're going to evaluate to 0 every factor. It will be x plus 3 is equal to 0, and this will be later you will get the vertical asymptote number 1, and it will be minus 3. And the other vertical asymptote number 2 is going to be the same. You have to evaluate to 0, and then you get 2.
Okay, so now I'm going to show you how to find or how to get the vertical asymptote and the horizontal asymptote. Okay, so we have two examples, this one and this one. We're going to start with this one. So first you need to analyze this function. So in order to find the vertical asymptote, you need to take the bottom part. So we start x plus 2 equals to 0, x equals to minus 2. The other one, x minus 1 equals to 0, x equals to 1. So these are my two vertical asymptotes. Okay, so now I'm going to go with the next example. We take this one, x plus 1 equals to 0, so x equals to minus 1, vertical asymptote, and my horizontal asymptote would be minus 3, so y equals to minus 3, so we put horizontal asymptote y equals to minus 3.
Okay, this is a rational function, and first we are going to check if this has gaps. The first step is factorizing the two polynomials, and if you don't find like same numbers in the parentheses, you know you cannot cancel them, so there is no gaps. And for finding the vertical asymptote, you have to evaluate the function with 0 and 2x, and then you've got the vertical asymptote 1 and 2.
So now for finding the horizontal asymptote, since the degree of the numerator is larger than the one from the denominator, there is no horizontal asymptote as such. And here are the domain and range. The domain includes all the numbers from minus infinity not including 1, a union between not including 1 nor 2, and a union not including 2 to infinite. And the range is y from minus infinity to not including 0, and union from not including 0 to infinity, and also the y-intercepts and the x-intercepts. In this you need to substitute x for 0 for finding the y-intercept, and the inverse for the y-intercept. So in here we found that the y-intercept is minus 4, and the x-asymptote is 2.
To conclude our math problem, we managed to solve and graph our rational function. you can see we managed to factorize first, and we were able to right away identify there were no gaps in our vertical asymptote. And as you can see, as the leading term told us that there was no horizontal asymptote. It does not exist. We managed to identify the range and the domain, as you can see in the graph.
So to find piecewise functions, first we need to look at the functions displayed and determine where to stop the graph, which are the conditions. We'll call them conditions here. Alright, we've got a radical function which is square root of minus x minus 2. When we graph it, it should look like this. It should start in minus 2 because of the transformations it undergoes. And we should include it because of the white line. It says here, maybe you cannot see it, but it says here, x is smaller but includes minus 2, less or equal than 2. Than minus 2. So we put a black dot over here. Then minus 1/2 of x minus 2 is a linear function. In here we do the slope, we locate the y-intercept, and then we do the we already did the transformations. Now we do the conditions. Stops in minus 2, we do not put we do not include the points from minus 2 to 1. And then in this quadratic equation we can find the roots, which are 1, 0 and 3, 0, and we can use them to graph this function. This was the easy part because we could also find the asymmetric line, the line of symmetry of this graph. So we include 1, 0, and we do the graph all the way up. So the domain is minus x equals minus infinite, comma 2 include minus 2 included, union minus 2 not included, 1 not included, union 1 included, infinite. The x-intercepts, of course, are minus 2, 0, 1, 0, and 3, 0. The y-intercepts is 0, minus 2, and the range is y equals to minus infinite, 0, union minus 1, minus 5/5, because it ends here. It does not end in even in a concrete number, and minus 1 to infinite because of this point over here. That's it.
At the end, we managed to graph and identify the conditions of each piecewise function, also determining their domain and range, along with their x and y intercepts. By the end of this project, we learned that functions graph can come out to be really useful. We also learned while doing the project how to graph and find details in rational and piecewise functions that help facilitate the graphing process easily. In other words, we can now see and understand the useful details and applications of graphing.